Number 14. What point in the feasible region maximizes the objective function? So they've given us our inequalities. All right, I got to graph those, find the vertices, take those numbers, plug them in here for cost equals 4x minus 4y, and then I want the maximum here. So I'm going to use the calculator to help me graph, kind of shortcut things a little bit. So I want x is greater than 0. So for that one, what I'm going to do is just make my window start at x is greater than 0, just so it doesn't show anything else. Y is greater than 0, we'll do the same thing there. Our minimum will be 0, and then we want bigger than that. Then I can go to y equals. I've got negative x plus 5. And then we have 1/3 of x plus 3. Okay, I'm going to zoom in a bit. So let's see, we've got 1, 2, 3, 4, 5. So let's change our window. Let's go from 0 to 6. And we've got 1, 2, 3, 4, 5. Let's make this a 5, just so we can get a nice good look. I'm going to hit trace. So I want to know my vertices. So we got to show our work. So I want to get that graph going. I have vertices here, 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 and here. So those are the points we're going to use. So this one's 0, 0. Got that. This one looks like 1.5 and 3.5, perhaps. And this one's at 0, 1, 2, 3. And then this one down here is at 1, 2, 3, 4, 5, 0. So we have our cost function. We're looking for that maximum. So 4 times 0 minus 4 times 0 for this point. 4 times 0 minus 4 times 3 for this one. 4 times 1.5 minus 4 times 3.5 for this one. And we've got 4 times 5 minus 4 times 0. Okay, this one's going to be 0 minus 0, which is 0. Here we're going to have 0 minus 12. This one, even if you do the math, this is the bigger number, so it's going to be minus something bigger. So this one also is going to give you a negative answer. And this one's going to be 20 minus 0, which is a positive 20. So that, we were looking for the maximum in this case, maximizes. So the point 5, 0 maximizes the objective function to 20. There's your final answer.